Hey, welcome back. Good to see you again. Thanks for joining the channel. Hope you're all well. Today on the bench I have a Rotel stereo power amplifier. This is an RB-850. Very plain looking black box with, oh, it's heavy. It has got some weight to it. It's packing something inside. Very black and plain and nondescript. This was a gift to the donation to the channel by one of my subscriber clients, Dean. Thank you, Dean. It was surplus to his requirements. It was broken. He says it has a bad channel, and we're going to get to the bottom of that. We're going to make sure that doesn't happen. But he decided to donate to the cause, and here it is. We're going to go through, make a video on it, see what the problem is, fix it up, maybe do some other things, cleaning. Obviously it needs cleaning, and who knows what else we can find. But yeah, nice. And there's there's no controls on here. There's a power button, okay, 2 LEDs. One says power, one says bridge mono. So you can put this into a bridge mode and run it as a mono block, which is what he was doing. I think he has 2 of these, or did. Okay, we've got inputs for left and right. We have a switch for mono or stereo. It was in the mono mode. Maybe that's why it wasn't working, because it was stuck in the mono. No, you should get sound out of both sides, but it would be the same, just inverted. I don't know, we'll test this theory. We'll test if that's the problem. 2 courtesy outlets, it's both switched. And then a power cord, input power cord. Very, very sparse. 1 set of speaker connections, that's all you get. On the bottom we have 2 access panels, cutouts for ventilation and heat sinking. And we have a sticker here, made in Taiwan. That's not good. Can't help you if that's true. Well, we'll see. So we got 3, 6, 8 screws to take out, and the lid comes off. This is all bent up here. The bottom plate is bent. I wonder if it took a hit or if something was sitting here and crushed it. So it does have this black anodized front. And it's very nice looking, but it's very, I don't know, it's just black, and everything's black, so it's really not remarkable. It's just there. So I think I have to pull this off the back somehow. Let me see. There we go. Ooh, it's dusty. Oh, look at this thing. Wow. Built to be low profile, for sure. Little shot of dust in my mouth. Exclusive high performance component. Did you see that? And then they have a sticker here for the power transformer. I guess they're showing off that it has multiple taps, and it does, if this is our primary. So we can reconfigure this for any voltage region. A lot of dust. And he says 1 channel's out. So let me get, I think I'll get a vacuum cleaner and suck up all this dust rather than blowing it out into the room. And yeah, looks like a nice design. We've got access panels under this and this. Let's see here, what do we have? Fuses look intact. I don't see any problem with the fusing. Oh wait. Yeah, this fuse is gone. I don't know if you can see this. Show this in the camera. See the ends of the wire? Okay, that fuse is shot. And that is a 4 amp, I believe. 4 amp, yes. This one here. This one's still good. So we popped the 4 amp fuse. And these 2 look intact. Okay, so our trouble's on this side. Alright. Okay, let me clean this up and then I'll bring you back in. On the bottom we have two access panels, which gives us, stuck, gives us some access to the underside. See a lot of flux here. I don't see, right off the top of my head, I don't see any cracked solders, but I'm going to inspect this. Why is it stuck like that? There we go. And give this a good inspection. Really not much to these amplifiers. They're pretty basic design, contemporary design. No cracks there. Let me try this side. Nothing going on there. I'm not seeing anything jumping out at me, but I need to clean up this flux and then I'll get a good look at it. Be nice if I could get the board out, but the filter caps are here. I like to inspect the joints on filter caps too, because they've been known to crack. I've seen that before many times on the bulk filter caps, as they have crack connections. That's why they glue them down to the board to prevent that, but it doesn't always work. The glue dries up and then the cracks develop, and then you've got problems with your amplifiers. Okay, so yesterday I cleaned this up and then I put it aside. I was going to get to it the next day, and here it is next day. And I had a little think about this. I happen to think there's nothing wrong with this amplifier. To tell you the truth, I think it's working perfectly as intended, as it came out of the factory. And let me tell you, let's do some checks first. I'm going to pull all these 4 fuses, and then we're going to check all our power devices on this channel, because this is the one with the blown fuse. This one was intact, so I think we're okay. It was working. So let's check the power devices on this channel, see if we have any short circuits. And I have a feeling there's none. So let me put my thing in diode mode here, and let's go through. Can you see that? No, you can't. Let's see if I do it this way. Alright. That's a normal junction. That's not a normal junction. Let's try this one. Normal junction. Not a normal junction. Okay, so maybe we do have bad transistors. I'm not sure yet. We'll see. Normal junction. Not a normal junction. So we don't have any shorts on any of these devices. I am measuring across the terminals. Okay, let's compare that to the other channel. And let's see if it's the same or if it's different. Alright. Okay. No, I think I need it this way. Yeah, see, it's measuring the same as our good channel. So I happen to think there's nothing wrong with any of these transistors, and the amplifiers are both working fine. Alright, looking good. So here I got a couple of 2 amp fuses. 2 amp, 125 volts, 125 volts, both the same. And on this I have 5 amps on my current regulated. So let's blow this fuse and let's examine it. Okay, that fuse popped. Now if you can see this, but there's definitely staining going on the inside of that glass tube. It wasn't very spectacular because I didn't really use a high current. Let's see, we got 5 amps. Let's try this one. Let's try this one at 2 amps. This one I got 2 amps on the current regulated supply, so let's connect this side up. Let's connect this side. And the fuse held. Okay, we got a short circuit on my supply right now. So let's zoom in. Okay, we got our fuse. We're getting a glare. Maybe I could turn the lights down a bit. It doesn't really help. If I do this, maybe. Okay, we got our fuse there, but we got glare. So I'm going to slowly increase the current on the power supply. I'm going to go up to 2.2, 2.3, 2.4, 2.5 amps. This is what's going on here. 0.6, 0.7, 8, 9, 3 amps. It popped. I don't know if you saw that, but that popped at 3 amps. This is a 2 amp fuse. It got quite warm too. So if you look inside the glass, there's no staining on the inside of the glass like there was with this one. Okay. On the first one, we put enough current in to vaporize some of that filament, and the vapors deposited themselves on the inside of the glass, which made that stain. On the second one, we slowly increased the current, and the wire got hotter and hotter to the point where it just melted and gave way, and then it just let go. And there was no real vaporization. It was just a matter of the metal turned to liquid and it just kind of fell apart. And so that's what I kind of think happened here in this case with this fuse. You see there's no staining on the inside of the glass. It just kind of got hot enough, and then it melted, and then it separated. Okay. This wasn't a hard short. That's what told me that it wasn't one of the output transistors that shorted and causing a hard short in the power supply. It was more either a gradual overload or this fuse failed from fatigue. You know, these fuses can fail from fatigue, especially when this little wire here heats up and cools down, heats up and cools down every time you put current to it. Power cycling the amplifier would cause this to heat up for a moment and then cool down. And that kind of, what it does to the metal is it kind of fatigues it, and then it gets weaker. And I think that's what happened in this case. So you can tell if a fuse is hard blown, the inside of the glass will be all black and silvery, and you won't be able to see through it, like this one. But this was kind of a bad example. They really didn't do a spectacular job on that front. All right, throw those two away. Okay, so there's 4 caps in this thing altogether, 2 in each channel. One of them is back here. It's 100 microfarad, 6.3 volts. This is a 1 microfarad at 50. And those are the only 2 caps in each amplifier, other than the mains. So let's check with our tester if we can get a reading on these, see if they're healthy or not. Why is it reading resistance? It's not a resistor. Okay, we've got 80 microfarads on that one, so it's down. This one here is 1 microfarad. Let's test this one out. And it's showing 958 nanofarads, which is normal. Alright, let's check the other channel. Here's the other channel. If you can see this, I hope you can. Okay, so this one reads 66 microfarads, so that cap is done. This one here. This one here, let me see if I can get a read on this one. That's the problem with these tweezer ones. You can't get in sometimes. This one's rating 736 nanofarads. So it's at 75% of what it should be. So what I'm going to do is I'm going to replace these 4 caps, and then that's pretty much all I can do for this amp. Okay, so I went through the board, touched up quite a few joints on transistors. Not that they were cracked, it's just they were low on solder, and with the wave soldering that they use on these boards, some joints come out good, some joints come out with low solder. So when it's got low solder like that, it's a weak joint, and you can easily crack just from temperature cycling or vibration. You can get a crack in a joint. So I just flowed them out and made them a lot more stronger. Not that there was anything wrong with them. I didn't find any crack joints. Alright, let's pop our fuses back in. 4 amp. The fuses are in between the power supply and the amplifier circuits. So transformer goes into the bridge rectifier, caps, and then through the fuses, and then transistors. So these fuses don't see any current when you turn the amplifier on to charge these caps. The current flows past the through the bridge rectifier, and that's it. Pretty much it. So I got the fuses in. Let's plug it in and power this up for the first time. Alright, here we go. Power on. Up to about 95 watts, down to 21. And looks like it's idling right around 21. And I will set the bias, find out what the value is, and I'll set the bias. There is 2 trim pots here. So I'll let this idle for a bit, and then I'll come back and I'll bring you back in. Alright, setting bias is very easy. There's 4 test points. Test points 1 and 3. Right here there's 2 pins. Can't really see them, they're behind this emitter resistor, but you can see there's 2 pins here. And then test point 2 and 4 is on this side. So you just connect your voltmeter up to those 2 pins. And do 1 channel at a time. Put it on millivolts. And then turn it on. And the spec is 4 millivolts. So right now we're at 3. It's slowly going to climb up. So I'll let this warm up and stabilize. I'd give it, they say, sometimes they only say give it 2-3 minutes, but I say no. Give it 10, 15, 20 minutes even. Give it a chance to warm up and temperature stabilize before you do the biasing adjustment. And it looks like we're pretty close there on that channel anyway. Turned it on and we're consuming 23 watts. Slowly climbing up. And let me check the other channel while we're here. Yeah, a little bit high. Got both bias set to the correct value. Got to note that they rotate opposite of each other. So if you turn this one counterclockwise to turn it down, you got to turn this one clockwise to turn it down. That's what I mean. So they're both at 4, and our consumption has leveled off around 22.5 watts, which is ideal for an amplifier this size. Okay, let's connect it up to a load and see what it can do. Alright, let's do our power test here. Let's get it started. Got everything connected, I hope. Connected correctly, I hope. Plug this thing in and turn it on. Now I have 100 millivolt signal going in to start, so we'll see how this fires up. Instantly comes on. Alright, so we are live, and we're already putting out a fraction of a watt. Okay, let's go up in amplitude. 1 volt, and we are getting a little better. Okay, let's keep going. Okay, there's clipping. And back it off, and I'm going to back it off to this point, and I'm going to take my measurement here. 22.42 volts RMS. 216 watts going in, or thereabouts. And I'll start the timer, and I'll come back in 10 minutes, see how this goes. Alright, approaching the 10-minute mark now, and I'm amazed. This heatsink here and here, they're barely just above room temperature. This thing didn't break a sweat doing 10 minutes of full power. And it's kind of no surprise too, because it's got tandem outputs on a kind of a low power amplifier. This heatsink here is measuring 41 degrees, which is slightly above body temperature. This one here is 42, so it's a degree higher. The bridge rectifiers are getting a little warm. They're at 65 degrees, 67 on that one. Let's see what this one is. 65. Yeah, but they're standing out there in the open and they're not getting any help with a heatsink. Probably help if they put a bit of aluminum on there and bolted it down. But this thing's running really nice. I'm impressed. Nice and quiet. Transformers don't make a sound, and they are cold. There's no heat buildup in these transformers. Everything is just, this is incredible. Yeah, so I can see this would be great for doing 4 ohm loads, I think. Not much else to say about it. You just go on forever at full power. Alright, let's turn down the power, and then we'll go and try some square waves. Alright. There's our square wave at 1000 hertz. Let's go down in frequency. Hertz, looking good. 50 hertz, and then we go down 30, 20, 10. Starting to see limitations. It does have a big fat film cap on the input. I think it's a 1 microfarad. I'm not sure. Let me try paralleling another cap on top of this. This is 1 microfarad. Let's get a 2 microfarad and see what happens. Okay, here we go. I don't know if there's going to be any change on the scope. Okay, so the right channel, a little bit of improvement with increased capacitance, as you can see there. So it might benefit if you increase that input coupling capacitor in size. You probably get a little better, flatter response on the bottom end, if that's important to you. It's at 10 hertz. 20, 30, 40, 50. Let's go back to 1 kilohertz again. This time we're going to go higher. 10 kilohertz. Looking really nice at 10 kilohertz. Let's see how far we can go with this incredibly fast amplifier. Unbelievably fast. Okay, I'm going to go right up until we lose our square wave. And we are in the 150 kilohertz range and still going. So, yeah, this is incredible. Let's see how high we can go. That's 195, no, sorry, 295 kilohertz. And we're still getting a square wave out of this thing, more or less. Very fast amplifier. Incredibly fast. Up to 300 kilohertz. It's incredible. Nice. One thing I'm going to fix up here is these the glue for this LED is let go, and it's petrified. They used double-sided tape to hold the thing down, and then they ran a line of glue. The glue's failed. Glue's failed on these two, like these end caps. The glue's all crystallized, and so I'm going to re-glue a lot of this and then put it all back together, and then I'll be done. All right, here's a look at the parts that went into this. You have one glass fuse blown, 4 amp. And we have 4 caps. 2 of these are okay, 2 of them are dead, or dying, failed, whatever you want to call it. So it's good that we got in there and got those changed. And why did the fuse blow? Well, we don't know. The amplifier was perfectly fine when I tested it. And you saw it powered up fine after I put a new fuse in, and it works. Could be fatigue. Sometimes these fuses just fail from fatigue. The metal in the filament there gets weak with having power surge through it, and it could have been something other than maybe the owner had a short circuit in his wiring on his speakers, putting an overcurrent condition on the fuse, and it just popped. We don't know, but right now we've got a new fuse in and it's working, so that's as far as that goes. Alright, so that's as far as I'm going to take this one. Not much of a video, I know, but there wasn't much wrong with it. Now, I made a few comments earlier about being built in Taiwan. Don't let that sticker fool you. This is actually a well-built machine, and the build quality on this is actually pretty good, considering it does have a Taiwan sticker on it. And certainly impressed with how it performed on the power test. I was really impressed. This thing is built to perform, and I think it's a very capable amplifier. 65 watts per channel and 8 ohms, but then you could probably run this on 4 ohm loads all day long and it wouldn't bother it one bit. Or you could run it in bridge mode and double your power into 8 ohms or even more in 4 ohms. So nice amplifier. Little disappointing in the looks, a little plain, but I think that's okay. But anyways, that's going to end it here. So take care, and we'll see you on the next one. Thanks for watching.